Welcome back to our YouTube channel, Aman Codes. In today's episode, we are going to discuss about logical operators. Logical operators is also called as comparison operators. So in previous episode, we have discussed the relational operators, right? So that relational operators and these logical operators both are called as comparison operators. So let's see what is this logical operators. The purpose of logical operators is that to combine two or more relational expressions. So, in order to combine two or more relational expressions, we are going to use these logical operators. So, for example, we have a relational expression like a greater than b. So, in order to combine these two relational expressions, we are going to use here logical operators. So let's see what are the logical operators. If two or more relational expressions connected with logical operators, then it is called as logical expressions. The result of logical expressions can be either true or false. So same like in relational operator, the results of relational expressions is true or false, right? So here also same, logical expression results either true or false. The logical expression is called compound test condition. So relational expression is known as simple test condition. This logical expression is known as compound test condition because it is going to compare two or more relational expressions. So that is the reason it is known as compound test condition. It is testing two or more relational expressions. So whose result can be either true or false. In Python programming, we have three logical operators. They are given in the following. So we have three logical operators. So first is and, second is or, third is not. So this and meaning is physical anding. So this or meaning is physical oring. So these are the IEEE standard words. In today's episode, we are going to discuss about logical operator called AND operator. See here, AND operator. So let's see the syntax. Relational expression 1 and relational expression 2. The functionality of AND operator is given in the following truth tables. So this AND operation is going to done by using this truth table. So let's see. Relational expression 1, relational expression 2, and this relational expression 1 and 2. So see here. So if relational expression 1 is true, if relational expression 2 is false, then relational expression 1 and relational expression 2 is going to be false. So this relational expression 1 and relational expression 2 is going to be decided by using multiplication. How in the sense? So internally PVM consider true as 1 and false as 0. So when we multiply 1 with 0, the output is 0, right? So when we do this true with false, the output is false. So false and true. Internally false is considered 0, true is considered 1. 0 and 1. In the sense 0 multiplies 1. So the output is also 0. In the sense false, right? So false and false. So false and false is false. 0 multiplies 0 is 0, right? True and true. So relation expression 1 is true, relation expression 2 is true. So true and true is true. In a sense, internally PVM considers this true as 1, this true as also 1. So 1 into 1 it is going to 1 only, right? So true. So this is the truth table regarding this AND operator. Short circuit evaluation in the case of AND operator. So let's see what is short circuit evaluation. So two or more logical expressions connected with the logical operators and see here two or more logical expressions in a sense A greater than B greater than C. They are connected with logical operator and, right? So two or more relational expressions are connected with logical operator and then it is known as logical expression. So this is a logical expression. And if the initial relational expression is evaluated as false, so if this expression is going to be false, then PVM will not evaluate rest of subsequent relational expressions. So whenever this relational expression is going to be false, so then PVM not evaluate the subsequent relational expression. Why in the sense? So first relational expression is false in the sense PVM internally treated as 0, right? 0 multiply with true or 0 multiply with false. The final answer is 0, right? So that is the reason it is not going to evaluate this subsequent relational expressions. See here, PVM will not evaluate rest of subsequent relational expression. So the result of entire logical expression is considered as false. So these process of evaluation is known as short circuit evaluation. So I'm repeating once again, whenever the first relational expression is going to be false, then PVM does not evaluate the subsequent relational expressions. So the entire logical expression result is going to be considered as false. So this type of evaluation is known as short circuit evaluation. So now I'm opening my Python command prompt. See here. First I'm going to consider this type of examples. True, false, false, right? So let's see it is right or wrong. True and false. See the output false, right? True and false has given output as false. Next, false and true, right? False and true. See the output is going to be false, right? So the next thing is false and false. So this false and false. See here the output is false, right? So next thing is true and true. The output is true. So according to our AND operator truth table, the output are false, 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 true, right? So see here, false, 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 true. So this is first kind of examples in this AND operators. So this is a level 1 of examples. So I'm going to level 2 of examples. See here, 10 greater than 20 and 30 greater than 40. So the output is, see how it is going to do in the sense. So 10 greater than 2. 10 greater than 2 is true or false. So 10 is not greater than 2. So then it is going to be false, right? So 10 greater than 2 is false. PVM does not execute this subsequent relational expression. Why in the sense? So it is false. False with true or false with false is going to be false only. So this type of evaluation is known as short circuit evaluation, right? So that is the reason the answer is going to be false. See here, answer is false, right? 10 greater than 5. So 10 greater than 5 is true, right? So when it is true, the PVM is going to evaluate this thing. See here, 30 greater than 40. So 30 is not greater than 40. So it is false, right? So the output is false because 1. So the output is false. Why in the sense? So the output is going to be false. Why in the sense? So true internally considered as 1, right? So false internally considered as 0. So AND operator is going to use multiplication. Then 1 multiplies 0, then the output is 0, right? So that is a reason output is going to be false. So for this entire logical expression, the output is going to be false. See here, the output is false, right? So if I do this thing, so see here, 3 less than 4. So 3 less than 4 is going to be true, right? And 5 greater than 2. 5 greater than 2 is going to be true. So true and true. The output is true. See here, output is true, right? So this output is true, right? So this type of evaluation is known as full length evaluation. Why we are calling this full length evaluation in the sense? So when first relational expression is going to be true, then automatically PVM will evaluate the next subsequent relational expression. So the next subsequent relational expression is also going to be true. Then it is going to search another is there or not. So another relational expressions are not there. So totally it has evaluated, right? So that is the reason we are calling this evaluation as full length evaluation. So 10 greater than 2 and 40 greater than 30 and 20 greater than 4. If we're going to see this thing, so 10 greater than 2, true, 40 greater than 30, true, 20 greater than 40, true. So this type of evaluation is also known as full length evaluation. The answer is going to be written as true. See here, true has been retrieved, right? So these examples are considered under level 2 examples. Level 3 examples, which is going to be some different type of examples. So let's see the level 3 examples. I'm going to do this thing 100 and 500. Try to understand what is the output. So example is like this, right? 100 and 500. So 100 is non-zero, 500 is also a non-zero. So non-zero values is true, right? So 100 is true, 500 is also true. So when AND operation is going on, it is going to consider multiplication, right? So true has internally considered 1. So true has internally considered 1. 1 multiplies with 1, the output is 1, right? True. So who are thinking the output is true, they are wrong. It is not going to print output as true. It is going to print the output as 500. See, so I'm going to execute this statement. See here. So here the output we got as 500, right? So why we got 500 in the sense? So see here, when this is true and false, the answer is going to get false. When false and true, it is going to execute a short circuit evaluation. So see here, when true and true, it is going to print output as true, right? So if you come here, when it is a true and false, then the output is false. So it is going to consider the last value or last expression, right? So see here also, true and true, it is going to take this last value. So that is the reason we got the output as true and we got the output as false. So come here, 100 and 500. So the same scenario is happening here also. See, when true, true, last true is considered as output. See here, when true and false, last false is going to consider as output. So like that way, here, 100 and 500, the output is 500. So see here, I'm going to take this thing, minus 200 and minus 900. The output is going to be minus 900. See here, minus 900. So 560 and minus 450. The output is going to be minus 450. So minus 78 and 46. See, the output is going to be 46. So these level 3 type of examples are more important. So if we are going to do this thing, what 0 and 45, the answer is going to be 0. See here, why the answer is going to be 0 in the sense, so 0 and 45, 0 is internally going to considered as false. So in this AND operator, if the first relational expression or this first condition is going to be false, so PVM does not evaluate the subsequent relational expressions or the subsequent relational data of this AND operator. So that is the reason it is going to be retrieve the value as false. So in the place of false, it is going to retrieve this 0 because I'm using these values, right? So if you consider this thing 45 and 0, then the output is 0. When this value is true, it is going to evaluate the next value. So the next value is going to be false. So the result is 0. Python and 200, the answer is going to be 200. So why in the sense? So this Python is an string, right? So in bool type data type, I have said that whenever the string is there, it is going to consider length of string. So when the length of string is non-zero, then it is going to consider as a true. When the length of string is zero, then it is going to consider as false, right? So here length of string is non-zero, then it is true. It is going to evaluate the next subsequent value. So next subsequent value is also true. So then it is going to print that value. See here, the output is 200. So when I try to do this thing, Python and an empty string, the output is empty string, right? So single quotes like this, it is going to print. The output is like this, right? So when I'm going to do this thing, Java and Python and DSA, it is going to take the length of this string. So length of string is non-zero, then it is true. And it is going to evaluate this thing non-zero, true, and it is going to evaluate this thing. Non-zero, it is also true. So then it is going to print this DSA as an output. See here, DSA as output, right? True and false and true. So before I'm explaining, you understand these previous concepts and try to answer yourself. So now I'm going to explain this thing. So this true is declared in double quotes, right? So then it is a string. So length of string is non-zero, then it is going to be true. So the PVM is going to evaluate this false. Here also we are considering length of string. It is also non-zero, so true. So PVM is going to evaluate the next subsequent value. Here we have true. Internally true is considered as 1. So true and true and true. Then the output is true, right? So in the output, we are getting the answer as true. See, the output is true, right? So if I do this thing, here I'm going to declare false. Then the output is false. So like that, if I declare binary value 1010 and binary value of 111, then the output is going to be retrieved as 7. See here, 7, right? So this 0B1010 is a value of 10. See here, 10, right? So the 0B111 is 7. So this value is 10, right? So 10 is a non-zero. So it is true. It is going to evaluate 0B111. So it is an 7. 7 is a non-zero. So then it is going to evaluate as true. So this value is considered 7, right? So that is the reason we got the answer as 7. So why we does not get the answer as 0B111 in the sense Python is an high level programming language. So Python converts this low level language into human understandable language or end user understandable language because Python is an high level programming language. So the last example like this 0B1010 and 0B111 and 0B000. So the output is going to be retrieved as 0. See here 0. So these are the level 3 examples which are most important. So this is all about today's logical operator and operator. So that's all for today's episode. I hope you all understand. Don't forget to like, share and subscribe to Aman Codes. Thank you so much for watching.